Welcome to day 20, 4.1 Antiderivatives and Indefinite Integration Part 2. All right, so in the last video we talked about finding antiderivatives or the indefinite integrals, right? And we kept it with the plus c. Today we're going to find what that c value is. We're going to find particular equations, okay? So before we do that, let's just talk about slope fields. So a slope field or a direction field consists of line segments with slopes given by the differential equation, or the first derivative. These line segments give a visual perspective of the slopes of the solutions of the differential equation. So for instance, we can sketch two approximate solutions. I just sketched one through the point 4, 2 for now, okay? For the differential equation on the slope field. One will pass through this given point, which is what I drew, and you can see that one, I use the entire grid, and two, I'm just following the little line segments throughout. So if we wanted to draw another one through any given point, I always start on the edge and I follow through all the way to the end. Okay, so slope fields, one thing you have to remember, they must use, or you must use, the entire grid edge to edge, okay? And what these represent are different families of the antiderivative. So if I wanted to solve for the function and take the integral of this guy, I would get an equation with a plus c, okay? And that plus c is just saying we're shifting up and down with our equation. And one is going to go through the point 4, 2, that's this guy. So what we're going to do next is we're going to actually find the particular equation for the solution of this differential equation that passes through 4, 2. Okay, so the second part is actually finding the equation. So we're going to use integration to find the particular solution to the differential equation, and we can use the graphing utility to graph the solution, and you'll see it's going to be what we had above in pink. We'll compare the result with the sketches in part A. Okay, so here's our differential equation. So the first thing we want to do is multiply both sides by dx. So we really have dy is equal to 1/2 x minus 1 times dx. And then we're going to take the integral. When you take the integral of dy, we're just left with y. And now we have to integrate the right side. So remember, we keep that coefficient, and now we're going to add 1 to our power of x and divide by that same power, and then minus 1 and add an x there, and we can't forget about the plus c. Today we're going to find the c value by evaluating this equation at the point 4, 2, because that's the point it passes through. So now we go ahead to find c. We plug in 4 for x and 2 for y, and we go through and we find that c is equal to 2. So now we can go ahead and write the particular equation. So now we can plug c in, 2 in for c, and we get our particular equation of y equals x squared over 4 minus x plus 2. Try example 2 on your own. Find the equation y given the derivative dy dx equals 3x squared minus 2, and it passes through the point 2, 6. Okay? Go ahead, try it, and let's compare answers. Take a look at my work here. After I went through and found the antiderivative, I got y is equal to x cubed minus 2x plus c. Evaluating that when x equals 2 and y equals 6, I found that c is equal to 2. So my particular equation is y equals x cubed minus 2x plus 2. This next example, we want to solve the differential equation when we're given what f double prime is equal to. We're also told that f prime of 8 equals 5/8 and f of 8 equals 2. So we want to get all the way over to what f of x is equal to. We want the particular equation for f of x. So I'm going to zoom in first, and what we need to do is work backwards. We are given f double prime's equation. So we need to find f prime from there. we know that f double prime is simply, when we take the integral of f double prime, we'll be back to f prime. So f prime is equal to the integral of x to the negative 5/3 dx. When we integrate this, we end up with f prime equaling negative 3/2 x to the negative 2/3 plus c. Now, they gave us information that f prime of 8 equals 5/8. So we're going to use that piece of information to plug in 8 for x and set it equal to 5/8 and solve for c. So when we do that, we will get c to be 1. So then we're able to find that f prime is equal to negative 3/2 x to the negative 2/3 plus 1. But I'm not done. We need to find the equation for f of x. So how do we do that? Well, that means we need to integrate f prime. So now we're going to go through that motion. And we're going to find f by integrating or taking the antiderivative of f prime. So when we do that, we go through our motion and we get f of x equals negative 9/2 x to the 1/3 plus x plus c. We need to find c. So we're going to use the fact that f of 8 equals 2. So we'll plug 8 in for x and 2 in for y, or f of x, and we will solve for c. And when we do that, we get c to be 3. So now we can say our particular equation, or solving this differential equation, we get f of x equals 9/2 x to the 1/3 plus x plus 3. This next example isn't really an example, as it is a very important piece of calculus, okay? So we need to know the relationship between position function, velocity, and acceleration, all right? So for a given position function, s of t, what is the velocity function? Well, velocity is simply the derivative of our position function. So s prime is really equal to v of t. And what's the acceleration function? That's s double prime, okay? So in a nutshell, what we can do is we can look at some things here. If we call our position function s, then s prime, which we typically call v of t, is our velocity. And s double prime is really the derivative of velocity, which we call acceleration, a of t. So velocity is really it's a rate of change in distance over change in time. And the rate of change, or acceleration, is a rate of change, and it's the change in velocity over the change in time. Another key piece that you should make sure you jot down is we often talk about distance and speed as well. So distance is the integral of the absolute value of velocity. And speed is simply the absolute value of velocity. So like I said, these are very key pieces that come up an awful lot moving forward. Okay, so now if we work backwards, if I'm given an acceleration function, a of t, what's the velocity function? What's the position function? So this is just working backwards, okay? So if we have a of t is our acceleration, then how do we find velocity? We're simply taking the integral, or the antiderivative, of acceleration. And to find our position function, we're simply taking the integral, or the antiderivative of v of t, of our velocity. Okay? Now, let's suppose we look at this diagram and we talk about distance. Okay? So let's suppose at time t equals 0, our position is at -3. Okay, this is our position. At time t equals 2, our position is now at 3. At time t equals 3, our position is at -2. Okay, but what's the distance? Okay, so the distance, or the distance traveled, right? So it's really equal to the integral of the absolute value of the velocity. So if we look through, we're really just talking about how far we traveled, right? Okay, so we traveled 3 units, then 3 units here, and we went another 3 units and 2 units until time was up at t equals 3. So what's the total distance we traveled? Just adding those distances together, we get 11. So you can kind of see how the distance works. And this is going to get us into integrals, very more so about integrals. Okay, so now we're going to use the concept about the relationship between acceleration, velocity, and position function, okay, to find our actual position or our actual equation here. So this actually comes from our book, or actually it's similar to page 254, example 8 in our book. So a ball is thrown upwards with an initial velocity of 96 feet per second. So that means v of 0 equals 96. From an initial height of 112 feet. So that's our initial position. So s of 0 equals 112. Okay, so what we want to do is we want to find the position function given the height s as a function of time. So s of t. So before we can begin, what I want you to do is I want you to use negative 32 feet squared per second as acceleration due to gravity. Okay. So you might have to use this in one of the book problems later. They just assume that we know this, okay? So we're going to let a of t equals 32. In order to get to s of t, we need to do some integration. So the first thing we need to do is we need to find our velocity, okay? So we go through and we take the integral of our acceleration, and when we do, we get negative 32t plus c. Well, we know that our v of 0 was 96. Okay, that was given to us. So we're going to use that aspect to go ahead and find what our c value is. And so when we plug in 0 for x and set it equal to 96, we get c to be 96. So our velocity function, or s prime, is equal to negative 32t plus 96. Okay, so now we've got velocity. Now we can find our initial position, our initial function, okay, position function, I should say, by doing the same thing, but to the velocity. So now we're going to take the integral of our velocity, and when we do that, we get negative 16t squared plus 96t plus c. And remember, we were told that our initial position was 112. So we're going to use that fact to find our c value. And when you plug that in, we get c to be 112. So we get our initial position, or our position function, I should say, sorry, to be s of t equals negative 16t squared plus 96t plus 112. Okay, so I want you to finish this off. I want you to tell me, when does the ball hit the ground? So I want to know when s of t equals 0. Go ahead, work through it, and check back. Hopefully you got what I got. So setting it equal to 0, now all we have to do is factor out a negative 16, and then the rest factors nicely. So we get two answers, t equals negative 1 and t equals 7. Now time isn't going to be negative, so I can throw that guy out. Time has to be positive, so therefore the ball hits the ground 7 seconds after it was thrown. If you have any questions on finding the specific solutions to differential equations, make sure to ask in class.